Okay, guys, so let's go over quiz 6-1 first. This one we took right before the vacation, and it was basically just simplifying and the different radicals and exponential fractions. So we have 81 to the 1/2. An exponent of 1/2 is the same as a square root. So we're looking for the square root of 81. Because this was part of the original problem, you were not the one writing the square root. You can just put the answer as 9. It does not need to be plus or minus 9. You only put plus or minus when you are solving and you're the one that drew in the square root. Okay, so the answer for number 1 was just 9. So on quiz 1, each one was worth 1 point, so it was out of 13 total. Number 2, we have 27 over 64, and all of that is being raised to the 2/3. So remember, the denominator is the index when you are taking the root. So we can rewrite this as the cube root of 27 over 64, but we have to keep that exponent there as well. So we're raising the whole thing to the second power. So you want to take the cube root of both of these first. The cube root of 27 is 3, and the cube root of 64 is 4. I had a lot of you that gave me 3/4 as your answer because you forgot that we also have to square that. So when I square 3 over 4, that's going to give me 9 over 16. Number 3, we have 1,000 to the power of negative 1/3. We do have a negative exponent here. My suggestion is that you rewrite it first and simplify, and then take care of the negative exponent last. So our index here is 3. So that means I'm taking the cube root of 1,000 and raising it to the negative first power. So your denominator is the root, the numerator is the exponent. So you have to keep that exponent. All of you got that the cube root of 1,000 is 10. And so I got a lot of you that gave me an answer of 10. But remember, we're raising it to the negative first power. That negative exponent means that I have to move that 10 down to the denominator. So my answer would come out to 1 over 10. Remember, the negative exponent means it's in the wrong place, so I have to move it. A lot of you were still multiplying these two things together and giving me negative 10 as an answer. So make sure that you're paying attention that this is actually an exponent. We're not multiplying here. Number 4, negative 32 to the power of 1/5. So, like I said, my suggestion is that you rewrite it. So my index is 5. I am taking the 5th root of negative 32 and technically raising it to the first power. You don't have to write that though. Okay, because I'm taking a 5th root, is it okay that my inside is negative? Yes, when the index is odd, you can have negative. You guys should have this memorized by now. What is the 5th root of 32? 2. But since I'm looking for the 5th root of negative 32, what should it be? Negative 2. The reason why it's okay for it to be negative if you have an odd index is because when you're multiplying an odd number of times, you get a negative answer. So it's totally acceptable. It's just when you have an even that it can never be negative. Okay? So that's number 4. Number 5. We have the cube root of 1 over 4. Okay, since I'm taking the cube root of a fraction, what we like to do is we want to split these two things up. So that's going to be the cube root of 1 over the cube root of 4. And so now I have in the denominator a root, which I want to get rid of. But remember, this is a cube root, so I'm looking for groups of what? Of 3. I have in 4 two 2's already, so this could also be written as the cube root of 1 over the cube root of 2 squared. So same idea as when we were rationalizing with square roots. But I need to get 3 inside of here. I have two 2's already, so how many am I missing? Just 1. So I multiply the top and bottom by the cube root of 2. Because look at what happens. I can multiply the insides because my roots are the same. We can do that for multiplication and division. Addition and subtraction, the insides also have to be the same. But with multiplication, we can multiply them. So that's going to be the cube root of 2 all over the cube root of 2 cubed. So this is the cube root of 2 over, what's the cube root of 2 cubed, ladies and gentlemen? 2. So that's your answer. Yeah. You have to put the cube root. It does not magically turn into a square root. Okay? The index does make a difference, so make sure that you are including the index. Okay? Number 6, we have the cube root of 16 minus the cube root of 2. We did this on the AO yesterday, so I'm not going to do it. So you should have the correct work written down. The answer should have come out to the cube root of 2. So just as a reminder, that was your answer, but we did it yesterday in class. If you weren't here yesterday, get the correct work from somebody else's AO. Okay? Number 7, same thing. We did the AO, it as the AO yesterday. So that is the 4th root of 48, x to the 3rd, y to the 5th, z to the 8th. I'm not going to do all of the work because we already did it, but the answer should have been 2y z squared, 4th root of 3x cubed y. So that is the full answer. A lot of you were just forgetting to write the 4th root there, so make sure that you are paying attention to that. Okay. 8, 9, 10, 11, 12, and 13 were all true or false. So if you are doing corrections on this quiz, I don't want you to just write the opposite answer of what you put if you got it wrong. I need you to show the work. Okay, so we're going to do the work right now for those. Number 8, they gave us x to the 1/3 times x to the 1/2, and they're telling us that it should be equal to x to the 1/6. So it's our job to determine if that is true or false. So what we're going to do is we're going to take the left-hand side and work it out and see if we get the same answer. If I have x to the 1/3 times x to the 2/3, what do I do with those exponents? Do I add them, subtract them, multiply them, or divide them?
Oh, you can't do nothing.
You add them. So this is going to be x to the 1/3 plus 1/2. But I can't add them yet because I don't have what? What don't I have? A common denominator. What would the common denominator be? 6. So that's going to be x to the 2/6 plus 3/6 after you get common denominators. You can do that work yourselves. So that's going to give me x to the 5/6. Is that the same thing? So is this true or false? false. Did you put false? Yeah. Okay, I'll check. Number 9. 16 to the 3 over 2 is equal to 16 to the 1/2, all of that to the 3rd power. It would be really hard for us to take that left-hand side and break it down, so let's actually work with the right-hand side. 16 to the 1/2, all of that to the 3rd power. When I am multiplying powers, I add the exponents. When I'm raising a power to a power, what do I do with the exponents? I multiply. So this is going to be 16 to the 1/2 times 3. 3 by itself is the same as 3 over 1, so that's going to give me 16 to the 3 over 2. Are those the same? Yes, so it is true. Did I really?
I think you were just so happy marking the wrong that you just
I probably got off track in my grading. Okay, number 10. We're almost done. I have the cube root of 1/6. And I want to know if it is equal to, sorry guys, the cube root of 36 all over 6. Okay, so let's work with the left-hand side. The cube root of 1 over 6 is the same as the cube root of 1 over the cube root of 6. I have a root in the denominator, which is not allowed. So how many 6s am I missing if I'm looking for groups of 3? I have 1, so I'm missing 2. So multiply top and bottom by 6 to the 2nd power. The cube root of 1 times the cube root of 6 squared gives me the cube root of 6 squared, which is 36, over the cube root of 6 to the 3rd power. That's going to give me the cube root of 36 over the cube root of 6 cubed gives me 6. Are those the same? Yes, they are. So number 10 was true. Did you get that one, Tiffany? Did I mark it wrong? Okay. Number 11. 8 to the negative 1/2 is equal to the square root of negative 8 to the 1st power. I think most of you should have got this one correct. A power of negative means that I have to move it down to the bottom. So that's going to be 1 over 8 to the 1/2. And an exponent of 1/2 is the same as a square root. So this is 1 over the square root of 8. Am I allowed to have a square root in the denominator? No. If I'm looking for a square root, which is pairs of 2, and I have 1 under there, how many am I missing? 1. So multiply top and bottom by the square root of 8. That's going to give me the square root of 8 over root 8 times root 8 gives me 8. Are those two the same thing? Not at all. So number 11 was false. Okay, number 12, we have the 4th root of 18 to the 3rd power. And they say that it's equal to the 4th root of 18 to the 3rd on the inside. Okay, guys, the 4th root of 18 to the 3rd power, that's the same as the 4th root of 18 times the 4th root of 18 times the 4th root of 18. Do you agree? So that's the same as the 4th root, and I can multiply the insides together. So of 18 times 18 times 18, which is the 4th root of 18 to the 3rd power. So true or false? True. These are dots. Multiply. Okay, last one for quiz 1, number 13. 2 times 7 to the 1/2, and they say that it's equal to 14 to the 1/2. I'm going to tell you right away that this one is false. One reason being because these bases are not the same, so I cannot multiply them together. Another way that we could figure it out, this is 2 times 7 to the 1/2 is the same as the square root of 7. So this is 2 square root 7, which is definitely not 14 to the 1/2, right? So number 13 is false. Okay, for all those true false, you must show your work. Okay, let's do quiz 2 really quickly. So, quiz 6.2. Number 1, we have x cubed equals negative 125. So for quiz 2, we were given these exponential functions and we wanted to solve. So I need to get that exponent by itself, which in this case it already is. And I need to get rid of that cube. So what's the opposite of cubing something? Not square root, but cube root. So take the cube root of both sides. I'll get it later. Okay, the cube root of x cubed is going to give me x. If I'm taking the cube root, is it okay that I have a negative on the inside? Yes. What is the cube root of negative 125? Negative 5. Number 2. X minus 3 squared equals 16. First thing we have to make sure is that our squared term is by itself. This whole thing is in parentheses, so the squared term is by itself. But I need to figure out what the opposite of squaring something is. Square root. So you take the square root of both sides. Now, was I the one that physically drew in the square root? Yes, so that means my answer has to be what? Plus or minus 4. Add 3 to both sides. So that gives me x equals 3 plus or minus 4. And I warned you to nobody give me this as your answer because you can do this. 3 plus 4 gives me 7. 3 minus 4 gives me negative 1. This one was worth 2 points, 1 for each answer.
Isn't it 3 minus? Oh.
3 plus 4 and 3 minus 4. Okay, number 3. X to the power of 5 over 4. You need to make sure you get your exponent by itself. And remember, when you have a fraction that's an exponent, in order to get rid of it, we raise the whole thing to the reciprocal power. So I'm going to raise both sides to the power of 4 over 5. Why do I do this? Those 4's cancel and the 5's cancel. So that's going to give me x by itself equals 32 to the 4 over 5. Now we can do this, right? This is x equals the 5th root of 32, all of that to the 4th power. What's the 5th root of 32, guys? 2. So this is 2 to the 4th power, which gives me 16. That was worth 1 point. The whole quiz was out of 12. Number 4. 2x to the 3 over 2, plus 1 equals 55. My exponent term is not by itself yet, so I need to subtract 1 first. That gives me 2x to the 3 over 2 equals 54. And my exponent is still not by itself because this is the only thing the exponent is attached to. So I have to divide both sides by 2 first. So that's going to give me x to the 3 over 2 equals 27. Now, just like number 3, I'm going to raise both sides to the reciprocal. So that's 2 over 3 because the 2's cancel and the 3's cancel. So that gives me x equals the cube root of 27 to the 2nd power. So I just rewrote this. Cube root of 27 is 3, and 3 squared is 9. Number 5, the square root of x equals negative 4. I did not count this one. Only one person in all 3 of my classes got this question correct. And the reason being is because I was so trying to get you guys taking the quiz so quickly that I just totally forgot this and didn't remind you. Look at your problem. You have to think, does the problem even make sense? The square root of x equals negative 4. Could I plug anything in for x and get negative 4 as an answer? So it's no solution. Yeah. I forgot to go over this with you yesterday because I was so rushed trying to get you enough time to do your quiz. So I didn't count it. It did not count against you. But now you know. Okay? Number 6. We have the square root of x plus 3 equals 8. So when we look at this one, square root equals a positive. Does that make more sense? Yes, so now we can go straight into squaring both sides. So that's going to give you x plus 3 equals 64. Subtract 3 from both sides, so you get x equals 61. Almost done. Number 7. The square root of x plus 3 equals 8. That 3 is not underneath the square root, so you need to make sure that you're being careful of that. And I need to get the square root by itself first. So I have to subtract 3 from both sides. So that's going to give me the square root of x equals 5. Now we have to ask ourselves, does this make sense? When I take a square root, I always get a positive, right? So this answer makes sense. So to get rid of the square root, I square both sides. That's going to give me x equals 25. Number 8, the square root of x equals the square root of 8x minus 7. Both sides have a square root this time. So what we're going to do is square both sides. So that gives me x equals 8x minus 7. Let's combine like terms. So I'm going to subtract 8 from both sides, or 8x. That gives me negative 7x equals negative 7. Divide both sides by 7, so x equals positive 1. Number 9. X minus